My name is Chris Smith, and I'm an applications engineer with the manufacturing team here at CADline. First of all, we will need a 3D DWG file exported from the existing Revit model of the manufacturing facility. To save a 3D DWG for our factory design, it is as simple as selecting the 3D view in Revit, as we can see here, then follow the usual procedure for exporting a file. File, Export, CAD Formats, DWG. The file is then saved and shared with the factory design engineer. Now we have our 3D DWG file, we can go ahead and open this file in AutoCAD Architecture. From here, we will need to modify the data we've been given, as there may be information in the file that is no use to us and could hinder our ability to work optimally. Once the delete operation has completed, we can follow this with a purge command to completely remove all the unused data within the file. Then we unfreeze our wall and floor layers, ready for the next step. We can use point cloud data within our model as a reference to existing architectural or mechanical assets. For this project, we were lucky enough to have point cloud scan for our facility, which we can import directly from the factory ribbon in AutoCAD. When placing the point cloud data, we get the option to specify on screen where the scan data will be, as well as other options like overall, scale, and a rotation value. Once again, however, we see that the data provided, although very useful, can also be quite distracting and creates a very busy environment for our factory designers to work with. Here we can see our point cloud scan in the recap environment. We can use the scan location points to look at the scan data in real view to help us understand the data with high resolution 360-degree images. And we can get back to the point cloud environment by selecting the 3D view button at the bottom of the screen. There are options for lighting styles, both single and double direction, or no lighting style, two shader options, and some edge highlighting options. We see here that I have moved the top boundary past the extents of the roof, and we can now more easily access the information within the scan, like the individual mirror balls. If the shape we need is not a basic rectangle, we also have the option to create a fence around the points we want to select. Switch to the clip outside option, and we are left with just the middle production line. When we do save our project, note that once points are deleted, they cannot be recovered. So save as or having a master copy of your scan is strongly advised. As before, I will specify the insertion point as 000 to ensure the scan data is aligned correctly, and we are now ready to proceed to the Inventor environment. We can start to build our factory layout. Once the model has opened within Inventor, we see the wireframe of the factory extents, as well as the point cloud scan that we linked to our DWG file. To start building our factory, we need assets, like machinery, material handling equipment, safety equipment, and so on. Fortunately, Autodesk have put a lot of time and effort into their asset libraries, giving the designer hundreds of standard assets to choose from in the asset browser. The asset then snaps to my mouse cursor ready for placement. I can snap the asset to sketch points using the insertion point defined in the asset. To place the asset, we simply left-click. We then get an option to specify the orientation of the asset with snap points at each 90-degree interval. By manipulating my view and using the existing point cloud data, I can reposition my asset using the reposition triad to best match the existing fence. A quick view change, and we can see that the fence post on the right is roughly correct, but the rest of the safety fence does not match. We see for the safety fence asset, we have the option to change the number of panels. When the assets are placed in the Inventor environment, a 2D representation is also associated with the asset, This means that when we revert back to the AutoCAD environment, the asset will be displayed in our 2D layout environment as well, showing that all through the design process we have a live link between the 2D and 3D environment. By changing the view representation in AutoCAD to wireframe, we can hide the point cloud graphic to see our 2D fence asset. Here I will add a paper machine that closely resembles our existing factory machine. After a short wait while the factory layer updates, we see the new 3D representation of the machine we just inserted through AutoCAD. I can again use the reposition tools to match the asset with our point cloud data. Once we have a model we would like to use as an asset, we can select the Factory tab and choose the Asset Builder tool, working through the new ribbon to create our custom asset. When we have completed our factory project, we need to send the model data back to our Revit designers. Back in Revit, the DWG file can then be attached to the Revit model, and because our factory was created using the original Revit World Coordinate System, we can again import the factory layout to the origin point. Once the DWG has imported, we can hide some of the Revit elements to see inside the model, where we can see our factory elements within the Revit model. If, in the future, we make changes to our factory in Inventor, it is simply a matter of resaving the DWG file with the changes and then reloading the linked DWG file in Revit. The Revit model updates with the changes, showing we now have a link between our 3D mechanical data and the Revit architectural environment. In addition to working with Revit, we can also export our factory design into Navisworks. We can use the tools in Navisworks to look at our model, like the walk and fly tools, and add realism with collisions, gravity to fix our camera to the floor plane when using, and we can even see an avatar in third person. From here we can save our project file set for future use, as well as saving the Navisworks project for use in other software packages downstream.